to write music. It's a step sequencer. I think it's best to see. It's a step sequencer iterating the time on every line, which means it will start at the top and at the bottom, and each line will be a step of the step sequencer. Basically, it has 2 or 3 instructions by default, which is the MIDI note, the first instruction of every track, then the velocity, and renoise. I'll add a few ones like delayed note, panoramic, and a few other ones. So the problem, those are very interesting tools to write music in an efficient way. It's very easy and quick to write something that is working, and it's also quite precise with. So why Soundtracker with C-Sound? When I first discovered C-Sound score and orchestra, I thought maybe it could be great that the tracks of a tracker could contain as many columns as C-Sound can have parameters for an instrument. So the number of columns needed to be extensible, and it's not in many tracker softwares. And it's also a way to combine the precision of C-Sound synthesis with the facility of manipulating data in a grid, and also implement maybe some algorithmic solutions to make it work as a complex tool. Also, C-Sound Orchestra allows you can be polyphonic in itself. You don't have to write the polyphony in the score, but you can. And so having a score visualization in a tracker with polyphonic orchestra possibilities, I thought it could be interesting for this. Well, we will see the rest, I think. I think the best is, for me, would be to show you quickly how it works. Well, this is the current tracker I built. So let's play, for example. I don't know why there is a synchronization. Yeah, I know, exactly. So it's not a musical example, it's just sounds, but well, here is how it works. Here you have a track, which is basically the major component of a tracker software. The track can be resized itself in columns according to what you need in your instrument, how many parameters, P fields. The time is like on every tracker iterating over every lines as a step sequencer. It works with very close to C-Sound because it's C-Sound who triggers time. The sequencer is C-Sound in this case. So you can write an instrument name here, an instance number just here. Here is the date for like the P2 parameter, P3 parameter, the duration, and there the user-defined parameters. I will show you just after how you define them. You can change the number of lines of the current sequence. A sequence, you can have several ones, like it's just a time, like a set of lines, and the first will be played before the second, etc. You also have the ability, of course, to change the number of tracks here, to have more one. And there is a tempo track, which is particular because it is trying to be also as close as C-Sound T statements as possible. On the left part, if you write a number, for example, 20 and 80 for lines later, it will do an interpolation from 20 to 80. But then if you write on the right column, it will then jump immediately from 80 to 90, for example. Which is a way to write tempo as a flexible value. The second thing you have to know about this is that for duration, I had a big thought, because in most sound tracker softwares, on a track, if you have an event and 4 lines later another event, then the other event will most of the time stop the previous one. The previous one duration will be until there is another event. But what I thought, maybe it could be great to be able to make it quite different. So I implemented two calculations method that are based also on C-Sound score. The first one is instance, which means that it will look, every event will look for the next event of the same instance, same instrument. If you didn't specify one, for example here, it will look for the next event that that is the same instrument and doesn't have an instance too. So this is the basic implementation. The second one was more inspired from trackers, is occurrence, which means it will look for the next event, whether it is the same instrument or not. And the last one is known, which means there's no calculation of the duration, which means you have to specify it yourself, and you're responsible of what happens. So most of the things that you write, like things here in the spreadsheet, you can write anything you want. I think here, okay. Let's jump to the second section. This section is the curve editor. It's been designed to work with C-Sound Gen, and every of Gen editors here are designed to be working with that. So there are 3 modes to the curve editor. The first one is this one. You can draw like at points. It will be linear, and if you just curve it, it will be curved, exponential or logarithmically. The second mode is spline. This one can crash, I don't know. Okay, it worked. Which is working with Gen 8 from C-Sound. And the last one is Bezier curve, which is working with Bezier curve. It misses 1 point here. Okay. I can store it as function number 1 or number 2 or number new. The second implementation of Gen is waveforms, which is a bit experimental right now, and I have some issues when putting it on a higher, on a bigger screen. But on my window it works. Why? I will fix it soon. And there is supposed to be 2 other ones, which is a row spreadsheet with 1 column, designed to be raw data for Gen 2, and a 3-column spreadsheet, which is supposed to work with Gen 9 to write wavetables with partial specifications. The new feature I created in this version, which is the third of this small software, which is quite experimental, is a C-Sound editor. It's because in the last version, I used to have a very, very big CSD working in the back of my interface, and it was very messy, and it was very difficult to find a way to get out of it. So I decided to implement a way to write UDOs and instruments here, and you can just find them here. C-Sound will evaluate before to put it in the database that is at the back of the software, so that you cannot use an instrument that is not evaluated successfully by C-Sound. So this is and then it will autocomplete here if you try to look for an instrument. Well, that's the presentation. Well, the autocalculate mode to visualize for between, so I explained already. and this one is occurrence. It will auto-calculate between every event. Well, when you evaluate a piece of orchestra, like an instrument, for example, in the code editor, it will look recursively in the database for every required UDO. For example, if you use any UDO, I think we're soon out of time. If you require any UDO in this instrument you're trying to evaluate, it will include it in the evaluation and recursively until there is no more requirements. There are 4 output modes of this software. There is a CSD renderer to render just the plain CSD with required instruments and score, a real-time play mode as you saw, a record mode for real-time record, and offline audio renderer. Some of them are not really working right now. Well, this is the connection and callback between C-Sound and the software. So you can see that you can control the master value here with the slider that is on the top. You can, there are 3 callbacks coming from C-Sound to the software, passing by the callback queue. And this is almost done. Okay. Well, there are some features to come, which are mainly, the main one is algorithmic data manipulation, because for now it's been only thought to write precisely and easily some synthesis instructions. And I want to implement a Lua script editor to maybe fill automatically, according to algorithms, the data inside the spreadsheets, and some other tools. Here it is. I think we're out of time. Okay, perfect. There are also some other things I can implement and I want to implement. I mean, the sequence arrangement widget that is at the bottom is a way to rearrange sequences one to the other. Because right now, if you write a complex sequence, then it will be played before the next one. So which is quite, it's sad. Because sometimes when you create like a piece of music, a piece of like, I don't know, 1 minute, you want to put it at a certain place in your composition, but you will have to rearrange and maybe put it next and rearrange it. So this will allow to rearrange completely the full score. And macro implementation is to work with C-Sound macro. It's not very complex to explain. There is one more thing I didn't tell, is that, yeah, it's about CSD formatting singularities. Because there are 2 things that, well, the program will interpret what is in the spreadsheet, what is in the curve editors, what waveform it needs, etc., and what instrument is required to format a plain CSD file. But there are 2 things that are hidden from the user, which are 2 instruments. There is a metronome instrument, which is used for 2 things, mainly to trigger to the user interface on which line the sequencer, the C-Sound sequencer, is iterating, on which step. And it's also used to propagate via a channel set, the tempo value, the current tempo value to other instruments, so that you can use it with the grid or without the grid, as you wish. The second instrument is a master instrument, which is used to control maybe the global, the master volume, master amplitude, and if you need to output to disk some values, the master values out from the software. Here it is. I think it's done. Do anyone has any question?